Welcome grade 12s to another lesson with Learn Extra Live. We're here doing grade 12 chemistry. I'm here with Phil. I'm going to be his wingman for today.
Absolutely.
So ladies, send in those quotes because everyone seems to love Phil. So Phil, you actually tell us what we're doing today.
Okay, well, today we're actually taking a look at Doppler effect. We're going to take a look at the way that waves change their frequency when either the listener or the source of the sound is going to be changing. I'm going to be telling you where it happens and hopefully taking a little bit of a look at a really mean challenge question. So that's coming up.
All right. I've got the challenge question. I'm going to post it up for you guys. And guys, you know the drill. Best question gets the calculator. Also, I've got this nifty labeler, and I know you guys want that stuff, really handy for your pencil case and stuff. I know you guys always are jacking each other's pens. You know this labeler will help. So guys, make sure you get those questions in. And guys, I want to send a quick shout out to Liberty for sponsoring this. And guys, we will see you after this break. Welcome back, Mindsetters, to grade 12 chemistry. Guys, you know the drill, pens, pads, making notes, and hit me up on the Facebook page, www.facebook.com/learnextra. Guys, chat to me so I can chat to you, so I can chat to Phil, so you guys can get your answers, so you guys can be sharp when it comes to those tests. And guys, I'm going to hand you back to Phil, who's going to take over the rest of the lesson.
Thanks so much, Ty. Okay, as you've mentioned, we are starting to talk about a new section. Well, what we're actually going to do is we're going to shift gears out of chemistry. We're going to start with a section of physics. We've been doing a lot of organic chemistry up till now. What I'm going to be doing is a section of brand new physics, which grade 12s find both very difficult for no good reason. I'm going to show you why it's easy to do this section. We're going to give you some nice steps, and I'm going to show you how to work with the Doppler effect. Now, what I've done is I've tried to break it down into a couple of easy steps and to try and see if there's a nice, easily approachable way of doing some of these very difficult questions. Now, some of you have been complaining on the Facebook page that the challenge questions are too easy. Well, today's one is absolutely the challenge question that you are going to be doing. Now, this is a big challenge. I've taken it from an actual government past paper. It comes straight from them. I'm delivering it to you, and I want to see how you cope with this. Very, very difficult. You've got to cope with some serious maths, and I want to try see if I can't deconstruct it and try and work with it in a much, much easier way. So let's take a look at this thing which is called the Doppler effect. It's brand new. It's part of the wave section. It's got to be inside your exam. There is a Doppler effect question in every single matric paper every year from here on until they change the syllabus. And I've taken a look. That's not going to happen for quite some time. So the Doppler effect, what is it? Well, I've written it down here, and some of these words people are going to be very uncomfortable with. I said that it's a change in observed frequency of a wave that is due to a change in relative position between an observer and the source of the wave. Now, let me try and rephrase that in a nice, simple, easy to understand way. If one object is making either a sound or any type of wave, if it's getting closer to the thing which experiences the waves, or in other words, somebody who's listening to especially sound waves, if they're getting closer to each other or they're going further away from each other, that means that the frequency which is heard by the observer, the person listening, is going to be different. Let me rephrase that. If something's making a wave, something's receiving the wave or getting the wave. If they're getting closer to each other or further away from each other, that frequency which is going to be received is going to be slightly different to when it started at the source, the beginning of the wave. Now, we can calculate this, we can describe this, and I'm going to lead you through this section, and hopefully we're going to get something really nice out of it. But first, what we're going to do is we're going to post up this really mean challenge question. And I think Ty's busy posting that up onto the page, and here it goes. I think my producer's going to put it up on the screen nice and big, and I want to describe it to you. I want to highlight a few of the important things, and I don't want you guys to guess. If you guys are posting up answers on the Facebook page, no guesses whatsoever. I want you to come up with a good method, help your other mindsetters out, try and figure out how to work towards the final answer. I'm not sure if it's A, B, C, or D. We're not sure. I'm going to show you during the show how to do that. So an ambulance approaches a stationary observer. A frequency of 450 hertz is heard. So an ambulance, when it's approaching an observer, is making a frequency of 550 hertz being observed. That means that the listener is hearing that frequency. Now, when it passes, the frequency changes to 467 hertz. So when it was approaching, 540 hertz. When it was going away, 467 hertz was heard. What is the speed of the ambulance? Now, this is quite difficult. This is a very, very difficult question. Something else which you'll need to know is that the speed of sound is 340 meters per second. There's a lot of information, and you've got a couple of answers here. Was the ambulance traveling at 10 meters per second? Was it traveling at 15 meters per second, 20, or 25? We're not sure. So let's just go through and highlight the important information. Let's find out what's going on inside my question. So what I'm going to do is I'm just going to highlight the important numbers. So when we had an ambulance which was approaching, so that's an important piece of information. It's coming towards the observer. I'm finding that there is a frequency of 540 hertz. When it passes, so that means that when it's going away, we're finding that there's a different frequency which is being heard. So once it passes, the frequency changes to 467 hertz. Now, the hint that I'm going to give you is that there are two frequencies which are listened, observed frequencies. Now, that's the tough one. I'm actually giving you two answers, and I'm asking you to work backwards. So what is the speed of the ambulance? We're looking for the velocity or the speed of the ambulance when the speed of sound itself is 340 meters per second. Really, really tough challenge question. I hope mindsetters are on it and they're working hard at home. I'm telling you now, if you're getting it very quickly, it probably means that you're skipping out one of the steps. This is a very difficult question. So what we're going to do, let's get into the lesson. Let's find out exactly how I approach a Doppler question. And once again, I cannot emphasize this enough. Even if you haven't done the section at school, what we're going to try to do, break it down into basics and get you working through these problems anyway. I hope you got your notepad, your calculator at the ready, and we're going to work through a couple of questions. First, let's break it down. Let's find out why the Doppler effect happens, and that's coming up now. Okay. Now, when objects get closer or further apart, the frequency heard changes. Now, everybody has experienced the Doppler effect. Now, you can even imagine this inside your minds. So, when I've got a car which is passing, or even a siren, most of you can imagine that there's a certain sound when it approaches us at a certain frequency, and when it passes, that sound changes. Now, if you can imagine a race car on TV, the moment it actually passes, most of you have actually got the Doppler effect imprinted on your brain from watching TV. So if you can imagine that high pitch to that low pitch, so that starts out, and as it goes past, it goes, so the next time I hear you or hear anybody passing me in a motor car, what I can actually do is listen for the Doppler effect. So it starts out at that high frequency, and as it passes us, it starts going into the low frequency. So this is what it's all about. It's all about the observed frequency. So the reason that I've put the maths up on the board here is that I've chosen to look at our wave equation. Now, the velocity of the wave is not going to change. V, the velocity of the wave, is equal to frequency times lambda. The grade 10s should even know that. Grade 11s, if you're watching this still, this is an important equation. What I'm doing is I'm going to study the relationship between frequency and lambda. If I rearrange them, I find that there's a certain relationship here. Now, let's just make sure that I can write there. There we go. So I find that there's a relationship between frequency and lambda, which is my wavelength. This relationship is an inverse relationship. Please, it is not an indirect relationship, as I've heard some learners say. Frequency is inversely related or proportional to lambda. What does that actually mean in English, not in math speak? That means that if my wavelength changes one way, the frequency will change the other way. If my wavelength gets shorter, my frequency will go up. Let me repeat that again. If my wavelength gets smaller, that means that the frequency is going to go upwards. Now, don't worry if you're not absorbing all the mathsy stuff yet. We're going to take this very, very slowly and make sure that everyone's cottoning on to this. So let's break this down into steps. Well, how can I figure out what's going to happen to the frequency? Now, since we've changed from from chemistry into physics, what I want you to do is I want you to start thinking in pictures. Anytime I approach a physics, any sort of physics question, I'm going to be thinking in pictures. I want to think graphically. I want to have a picture inside my mind. What I've tried to do is actually draw a couple of pictures for you, and I'm sure that you're going to see why I'm not an art teacher and I'm teaching science instead. And I'd like to take a little bit of a look at what happens when I've got a vehicle which is moving. So what I've got over here is an ambulance. The reason that I've chosen an ambulance is because ambulance makes a really nice, loud noise. You can hear an ambulance which is moving through the traffic. It's producing sound waves as it moves out. Now, one of the things that I've drawn in here in the yellow is I've actually drawn what happens to the waves as it comes off the front of the vehicle. Okay, now I've asked a question here. What happens when objects change the distance between them? So I can be in front of this vehicle and I can be behind this vehicle. If I was in front of this vehicle, what's going to be happening is the waves are going to be coming towards me, and you'll notice something very special over here. So I'm telling you that if I'm in front of the vehicle, these wavelengths have become short. The wavelengths over here are squashed because the vehicle is following its own waves. Now, what I'm showing you here is that the vehicle is not allowing its waves to escape. It's following its own waves. And that means that the wavelengths are going to get shorter. What about the other side? What happens if I'm behind the vehicle? What I'm going to find is that you can see that the wavelengths are much more spaced out behind the vehicle. So what I'm seeing here is that I've got longer wavelengths behind this vehicle. So in front of it, when I've got something observing, so I can even draw in a little man there, an observer. That could be me. Okay? This is me once I've lost a lot of weight. Okay? But I've got an observer here which is waiting for these short wavelengths to come towards me. That's going to affect the way that I change the waves. An object which is making waves and is moving changes the spacing between the waves. That's what I'm trying to say. So that sound is not going to be the same as it was before. If I was behind and I changed my position to being behind, and I've lost my weight again, so I've got this very tiny observer there, what I'm noticing is that the spacing between the waves is going to be much, much longer. But now, wavelength is not what Doppler is about. Wavelength is all about the frequency. So what I'm going to do is I'm going to pay a little bit of attention to the frequency. Now, I hope that you can see that this change in shape is going to affect that frequency. And when you start taking a look at that challenge question, and I'm pretty sure Ty's watching a whole bunch of people discuss all of this on the Facebook page, very, very difficult question. You need to pay attention to what's happening to these waves. I've got a short wavelength in front when objects are approaching each other. When they're going apart from each other, I'm noticing that they're stretched out. It's quite easy to imagine that when things are going farther apart, that I can stretch the waves out. I actually think of them as a physical thing which can be pulled apart. So now, what is the effect of this on all of the frequency? Well, when I've got a short wavelength, remember that they have an inverse relationship. A short wavelength will result in a very, very high frequency. That's quite important. As the wavelength went small, the frequency went big, it went high. They went completely opposite. Now, what's happening behind the vehicle is of the exact same nature. If I've got long wavelengths, I'm pretty sure most of you at home are guessing this, what's going to be happening is that long wavelengths mean that the frequency becomes low. The wavelength went big, the frequency went small. They are opposite to each other. And I want you to be able to get this. This is the fundamental basis of the Doppler effect. Something which is making a sound and is moving is changing the way that the waves move out from that object. That's a lot of information to take in, and I'm pretty sure that the learners at home are starting to take this in and starting to approach a challenge question, but this is vital. Are the objects getting closer, or are they moving further away? That gives you the basis for understanding why Doppler happens. It doesn't give you any of the maths, and I want to start just with pictures. Physics always starts with pictures. What we're going to do is we're going to take a very short ad break. We're going to let people at home work on those challenge questions, and we're going to see what comes out of those. But right now, I think it's time for an ad break. What do you think, Ty?
I think so too. Because literally, as you posted it up, the page is set on fire. So I'm seeing so many different answers. But at home, people stop guessing. I'm seeing people who just wrote A, B, C, D as the answer. But guys, as I said, keep answering, and we'll see you after this break. Guys, welcome back to Mindset. This is Learn Extra Live. So guys, make sure you guys are tuned in, paying attention. I want to send a quick shout out to Liberty for sponsoring this. And guys, again, you know the drill. I've got these Casios to give away, the labeler. Then I've got this calculator as well. Best questions. Guys, stop guessing. Stop guessing. We want to make sure that you guys are actually getting the questions right. So we want proper answers and explanations, not just the actual answer, D, what. Make sure you're writing everything, because it's supposed to help everyone involved. And I'm going to hand over to Phil, who's going to stress that point.
Absolutely, Ty.
Oop.
Okay. All right. A lot of you at home are busy guessing and guessing and guessing. Like Ty says, a whole bunch of people are saying B, a lot of people saying D, and they're not actually giving explanations. Guys, to make this a little bit more of a challenge so that you're not guessing, and I actually want you to climb into that question, I want you to figure out the answer, because it's not exactly any of those answers, but it's close to one of them. I want 2 decimal places out of you with your answer. Okay, because this is going to stop you guys from guessing. I want you guys to get the exact answer which matches one of those options. I am going to tell you that your answer will round to one of those values. So if you do your calculations, if you're very, very careful, I want those 2 decimal places, and I want the correct answer together, because that calculator is awesome. I'm not just going to give it away to the first person who guesses, and that's not what we're in the business of. We want to teach you, and we want you to get this right, and we want you to try hard. Okay, now back to the way that we actually solve these Doppler questions. Now, Doppler questions, except the challenge question, are usually really, really easy. Now, the way that we approach them is actually really important. What I'm going to do is I'm going to break it down. We study the theory as to why the Doppler effect happened. Let's get into some of that math. Let's get you that calculator. So, if I climb into this, here is my all-important Doppler equation. Now, this Doppler equation looks very scary. Now, there's a whole bunch of stuff here which I do not recognize. There's a whole bunch of V's and F's and all this stuff, and there's pluses and minuses. I'm not sure what to do. Okay, well, first, let's figure out what all these letters mean. You should recognize F. F is one of those things that we've actually been dealing with in the show. So what I'm going to do is I'm going to move around my equation, I'm going to explain the pieces, and we're going to see what they are. I actually want you to write out this equation for yourself at home, and I want you to work with me, label it, study the equation, love the equation, because it's going to give you 15 marks at the end of the year. This equation can get you 15 marks with that explanation. Really nice. This equation itself is not that actually difficult to understand if we know what the pieces are. Okay, so now how do I figure out what the Doppler effect is? Well, first of all, the Doppler effect is to find this guy, FL, which is the frequency which is listened, or the listener frequency. This is a frequency which is a result of my calculations. The problem with the challenge question was I actually gave you 2 of these. Very nice clue. So what I'm going to do is I'm going to move around my equation and see where it came from. The one thing which I did not give you was Fs. Now, there's 2 ways of talking about this. This is either the source or the sound frequency. This is the frequency before we changed it using a Doppler effect. So this is a sound when it comes directly off that ambulance. Okay, so we've got a source frequency which is changing due to the Doppler effect. I've got a listener frequency, which is now the changed frequency. That is the result of the Doppler effect. Now, the reason that it changes was because of these 2. Either I've got the velocity of the listener, either the listener is moving through the waves, or the thing which is moving is making the waves. So in other words, the velocity of the source. So let's play around with these. The listener velocity, very easy to understand. VL is the listener velocity. And I'm pretty sure that you can actually guess VS is the velocity of the source. Now, what I've actually done is kept that label off here because it's cluttering things. So if you're writing, if you're taking notes at home, VS is the velocity of my source, or the speed of the source, or the thing where the sound came from. One last thing. This V over here, please don't get them confused. Okay, that V over there is the velocity of the waves. So the waves can be light, they can be sound, they can be any wave. Anything which can make waves can do the Doppler effect. In this case, we're dealing mostly with sound, and most of your past papers, most of the exams, have dealt with sound. I've seen a couple of questions in textbooks which actually use light And light can have the speed of light, which is a constant c. If you haven't got there, don't worry about it. But we can use the speed of light if we're dealing with light waves. Now, one of the effects of Doppler is this is one of the strangest things that people actually managed to see when they started looking through telescopes, very powerful telescopes, in the 1960s and 70s. What they actually noticed was using the Doppler effect, they could actually see the universe expanding because of the change in the frequency of the stars. The stars were giving out these light waves, but because the stars were moving away from each other, the Doppler effect actually changed the color. So if you're interested in that, and it's something which comes later on in the section, it's called red and blue shift. But that's not something to worry about when you're starting out Doppler. Doppler effect actually gives us some really amazing information about the universe. It allows scientists to calculate how old the universe is. Really, really amazing. It actually it's supporting evidence for the Big Bang Theory. Okay, so let's get back to our calculation. Let's see how I use this wonderful thing to get all my marks at the end of the year, how I figure out what the listener velocity is. Now, these pluses and minuses are something which I haven't talked about yet, and I've done that on purpose, because they tend to be a little bit confusing, and they really shouldn't be. It just means that sometimes I have to plus, sometimes I have to minus, and that's okay. I'll show you exactly when to do that. So let's get on to it. The first thing which I want you to be able to do is to predict if the frequency will be higher or lower because of the movement. Well, this is a little bit difficult. It's a little bit vague, but prediction is definitely your smartest tool. Okay? How do I predict if the frequency is going to go up or if it's going to go down? And what I've done is I've broken it down into 3 smaller points and hopefully help you out with that. So what I'm going to be doing is bringing up the other points. I think we've lost point 2. There it is. Okay, so it says the second step in all of that is to change the Doppler equation to match your prediction. Now, this is where you're actually going to start the equation. I've got the picture in my mind. I've got my prediction. The second one is to change the Doppler equation and make sure that this matches my prediction. Then, only then, right at the end of this, I start putting numbers inside. I substitute and then check that it agrees with what I've chosen. My prediction, otherwise known as a hypothesis, especially if I'm doing an experiment, will be that the frequency will either get higher or it will get lower. Let me just run through these steps at home. Some of you are making notes and you need a little bit of time and you're worried that I'm going too quickly. These 3 steps can be summarized as this. First, I've got to predict. I've got to make my prediction. This is my hypothesis. Then step 2 is to change the Doppler equation to match that to match that prediction rather. That prediction is going to be higher or lower, and I'm going to show you how to change this equation, and then, only then am I going to put some numbers in this picture. We are then going to substitute and then check that it matches up with what we've done. Because I can tell you now, step 1 is where you make or break your Doppler calculation. The really cool thing is, Doppler calculations, you can make many mistakes, and it's actually fine. All you need to do is change a couple of pluses and minuses. Not sure how the Facebook page is looking, but from the looks of Ty, it looks like it's quite busy. You're reading quite a lot there.
They're pouring in. We've got a couple of answers already, so people are already answering to those decimal places. So
this is a good sign. This is a really, really good sign. Okay, I want people to be following these steps. I want to be seeing these people actually set this up. I'm going to take a look in one of the ad breaks, and we're going to actually figure out how you guys are doing at home. Definitely. Because this is probably the hardest challenge question I've ever posted. You guys wanted a challenge, we gave it to you. Okay, so the question is, how did you guys get to those answers? How should we be approaching these Doppler questions? I need to predict, change the equation, then only substitute. Physics is not all about the equation. It's about the mental visualization. It's about the picture. It's about the science involved, setting everything up. The equation is actually very often the last step. And a lot of people say, okay, but the equation gets me the marks. But be sure that you've set everything up, that your substitution in your equation is actually the thing which does get you marks. These first 2 steps are going to make or break your question. Okay, so let's get into it. I'm going to work you through an example. Those guys that are bored or have given up on the worked example, earlier on that challenge question, I want you to work through this one with me. Hopefully I can get my director to put this up on the screen nice and big because there's a lot of information. I'm going to show you how to play around with this. Okay? And we're going to see a lot of people answering long before I finish this, and I want you guys to help each other through this. This is all what it's about. people helping each other on that page, and I'm sure that Ty's got his fingers busy there. I can see him typing away.
I'm there. I'm fiercely trying to get to all these people. I'm just like, okay, guys, keep going, keep going.
Okay, fantastic. That's really good to know that people are helping each other out, and there's a lot of conversation going on online. Okay, but what I've got here is a slightly easier example. For those of you that are just starting this out, this is easing you into it. Okay, so I've got a motorbike which speeds towards a stationary bystander. So that means that there is somebody standing there and there is a motorbike which is speeding towards. Okay, so that's the first important piece of information. I find out that the motorbike is heading towards. There's a lot of focus on, are the objects getting closer or further? There's your information. So towards a stationary bystander. So this means that the person who is listening to the waves is not moving. And this motorbike is moving at a speed, so a velocity, and we're given that speed of 40 meters per second. Sure, there's so much information. The only way that you can cope with a question with so much information is to work through it in pieces. Please, don't try and memorize everything as you go. What I'm going to show you is we've got to draw a little picture, and I'm going to draw you with you, and we're going to help each other with this. Okay, it tells me that the engine of this motorbike gives off a frequency of 1,000 hertz. So that means that the sound starts off at 1,000 hertz and that these waves move at 340 meters per second. So there's another important piece of information through the air. So that's the speed of a wave of sound when it travels roughly at sea level. Now, they must give that velocity to you. They can never assume that you know it because this speed actually changes. The speed of sound is only fixed at sea level, and that is around about 343 meters per second. It changes a lot. Up here in Gauteng, we move a little bit slow with our sound, and that's why sometimes I can't hear things. No, it's just joking. At 330 meters per second is around about our speed of sound up in Gauteng because the air molecules are slightly further apart. Okay, but all of that information aside, that is the speed of these waves. They must give them to you, unless they tell you that there are light waves. That means that you've actually got to use the speed of light, and that's on your information sheet. It's also given, but be very, very careful. You've got to know what type of wave you're moving at. Now, for the question, after all this information, I've got to calculate the frequency which is heard by the bystander. Okay, I've got all my information. I know that the motorbike and the bystander are approaching each other. They're going towards each other. The bystander is not moving. The bike is moving at a velocity of 40 meters per second, and the frequency that it gives off when they start from the engine is 1,000 hertz. And those waves are moving at 340 meters per second. So much information, but what I want you to do is to start to collect this. Now, we can actually do this together. One of the things that I'm going to quickly do with you is I'm actually going to draw this picture out. I'm going to show you just how bad my artwork is. I want you to do it with me, and I'm sure that people are going to be laughing all over the page. Okay, but I want you to bear with me. Now, I'd like to show you the process, the way that I actually collect information. I don't just want to show you a picture that's boring. I want people to scribble. I want people to get all crazy with their pens. And I actually want to show people how to draw out these questions. So if I've got my motorbike, and my motorbike is going to be speeding along, and we've got our motorbike, there it is, and we've got our person which is riding on his bike. He's also lost a lot of weight. He's looking very skinny. Okay, and we've got somebody who is going to be listening to these waves. Don't know what you think about that, Ty.
It's not bad. I'm a graphic designer. It's not bad. It's not bad.
Okay, but the basic idea is that I get a picture inside my mind. Okay, and the picture is that I've got waves which are coming out, and these waves are going to be approaching that bystander. Now they are approaching each other. That means that these waves are going to be smaller than they were before. So originally, they were 1,000 hertz. See how I'm using my drawing? What I'm going to be doing is I'm going to be collecting information all on this picture. It's a very nice way to organize your information. Our bystander or our listener is not moving. Velocity of the listener is 0. What about the bike? The bike was really moving it. Okay, moving at 100 kilometers per hour and much more than that actually. So the velocity of the source or the place that the sound was coming from was really moving it. So that was 40 meters per second. And we've started to collect all the information that we need. The only other piece of information which is really important is that I've got to show myself how quickly the sound waves were moving. And the sound waves, I'm not sure if if you guys can see the green very nicely, it's nice and bright and lumo here, is that the sound waves were moving at 340 meters per second. A little bit faster than the bike, but they were moving nonetheless. Okay, now I'm ready to actually start my question. A lot of people say, well, doesn't this waste your time? Okay, well, getting the question wrong is wasting your time. Collecting your information means that you get the question right. Organize yourself first. Okay, so let's make our prediction. Remember that the bike and the bystander were actually getting closer together. So what does that mean? That means that the wavelengths will be getting shorter, and here's the thing. Here is the prediction. When I start taking a look, will the frequency go up? Will it go down? And here it is. So let's see what's going on there. The frequency will be higher. There it is. There's my prediction. I've said that when two objects are getting closer to each other, the frequency will go up. If they're going further apart, it would be lower, but that's not the case. I know that the motorbike is getting closer, and that means that the frequency is going to be higher. I hope that that point goes through today. Sounds like you've got something in mind there.
No, like everyone's answering. They're just waiting for you to just get there. So they're like,
okay.
Ah!
I'm going to keep these guys waiting. I'm going to keep them in suspense a little bit longer. I'm going to draw this out. I'm going to make sure that even if people haven't done this section, it's really
They
nice.
get to
It's free
understand
marks. Absolutely. So step one, make your prediction. Motorbike's getting closer. That means that the frequency is going to be higher. So now comes the fun part, the part which I really like, the part that everyone doesn't like because it's a whole bunch of maths. I see this big formula and I get very intimidated. Okay, so what I'm going to be doing is I need to be able to change this thing into something which is going to help me, because it does. So what I want you to do is I want you to study what information I've got. Well, I've got this thing. I've definitely got, and let's make sure that we circle and we actually highlight. Let's highlight in some yellow. Let's find out what we've got. I've got the frequency of the source. I know what the frequency of that sound was. I know that it was 1,000 hertz. I knew that those sound waves were moving at 340, so I knew that I had this piece of information. So that means that I've got both of these velocities. The velocity of the listener was 0. So what I'm actually going to do is I'm going to simplify your life a little bit. If one of the objects is not moving, and that's usually the case, that means that you can actually scratch out that entire term. Very, very useful to know this. The velocity of the listener is 0, doesn't matter, so that means that I can remove it completely. I know that I've got the velocity of the source, and we've got it over there. So my velocity of my source, that piece of information I've got, all I've got to do is go find my frequency of my listener and figure out how to use this equation. Okay, so let's move on a little bit. So where does it go from there? I've simplified my equation. I've taken away the velocity of the listener. And this is what you should be sitting with at the moment. The only question is, do I choose plus or do I choose minus? So let's bring that up. Let's make that a little bit more clear. Let's bring that into the center of your screen. Which am I going to choose? Well, now remember at the beginning, I said that whatever we change this into should help us get to our prediction. Remember what I said, the frequency of the listened frequency, the listened frequency should be higher than the source frequency. I've got to choose a plus or minus, which is going to help me do that. This is actually kind of difficult because the plus and the minus is at the bottom. So what I'm trying to do is I'm trying to get this part of the equation to be bigger than it was before. Now, the question is, how do you change a fraction to become larger by changing the bottom? And the answer is over here. What I've actually done is I've simplified it to become a negative. The reason that I've chosen a negative is not to do with the fact that the distance is getting smaller. What I'm saying is that if you subtract from the bottom of a fraction, that means that this entire fraction gets larger. Now, I don't want you to stress about this. I don't want you to stress about the plus or the minus, because if you're wrong, you'll know it, and you can change it very, very easily. If you get an answer which doesn't agree with anything, just go back, change a plus into a minus, recalculate on one of these amazing calculators, and we'll be able to change this into something which gets you marks. Okay, so now I've got an equation, and now comes the fun part. What we're going to do is we're just going to put in numbers, we're going to get our answers out, we're going to love life, we're going to get our marks. So hold on with me, and we're nearly there. So the last step is to substitute and then check that the answer does match it. So I want you to bear with me. We're going to put in some numbers. We're going to see what comes out. All right. Now, where did I get all these numbers? remember that 340 was my velocity of the wave in air. There was no movement of your listener, so there's nothing else on top. On the bottom, I've got 340, which is my velocity of the sound again, and there it is. There's my bike's movement. This is what's causing all the problems. Now, if you're not sure if you got the plus or the minus right, what you can actually do is you can just put this bracket inside your calculator, and if the answer comes out to be greater than 1, that means that you've done your job correctly, because we want to increase the frequency. We want a frequency which comes out to be larger than 1,000. So if this entire thing is going to be greater than 1, that means that you've done your job correctly. So greater than 1 for this bracket means that it's going to increase the size of this, and we're going to win our marks. Okay, the only thing left to do is to reveal the answer. Let's see what comes out here, and let's see if people at home have been calculating with us. I hope that you're calculating ahead of us and managing to get the same answer as we are, and that is 1133.33 hertz. Last piece of information which we need to do. Let's check. Let's see if our answer is actually agreeing with what's going on here. So I've got 1133.33 hertz. Is this bigger than 1,000 like we predicted? It is. Absolutely. That means that we've done something correct. There's very little else that can actually go wrong in a Doppler question. If you follow the 3 steps, predict, and then we're going to change the equation, then we're going to substitute, we're going to find out an answer, and we're going to check it with the original. Ty, I hope that people are working hard at that at home. I think it's around about time for an ad break. What do you think?
Yeah, definitely. I think so, too. Because, yeah, everyone seems to be getting the answers, and I'm like, yes, that's what we like. So, guys, make sure you stay tuned. And, guys, make sure you go grab a little snack, get a little something for a little bit of energy, because we've got another intensive session. So make sure you come back, yeah? Get your notepads out, your pages out, and make sure you're writing that stuff down. And, guys, again, keep talking on the page, and we'll see you after this break. Welcome back, Mindsetters, to grade 12, chemistry today. And me and Phil actually talking about it, like, you guys are, I must say, like, clap, 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 clap. I'm impressed. Like, you guys are answering those questions, which is what we want. And guys, keep chatting to each other. Keep finding out, okay, what did you get? What did you get? Because that's the point of this entire platform. It's for you guys. Talk it out. Find out what's going on. And I'm actually handing it over to Phil now, who's going to actually tackle the question with you guys.
Absolutely. Thank you, Ty. Okay. Ty has been fielding a huge amount of questions, and I'm impressed, guys. You guys have been working hard at this. You've obviously been practicing, and that's just what I want to see. You've obviously been taking a look at some of the really impressive achievements of the Mindsetters, and you guys are really putting your head to this task. This is probably the most difficult Doppler question I have ever set, and it's probably the most difficult one which I've ever brought on the show, which is fantastic, and you guys are getting it. Okay. I'm not going to tell you the answer straight away. What I'm going to do is I'm going to work you through it. Even if you're one of those people that managed to get it right, it seems to be like drawing to some sort of consensus at home. But I want to try and figure out how I'm actually going to do this. Well, there's actually 2 Doppler equations. Now, what I wanted to do was to actually show you how to set this up just to be successful. Some people are really struggling, and that's normal. This is not a challenge question to try it if you've never done this before, but I want you to follow and see if you understand. Now, this challenge question says that I've got an ambulance which is approaching, and that's the key. The ambulance is first approaching. Here we go. It approaches. Wait a minute. Let's highlight that. There we go. Approaches. There we go. We got our information. Approaches. So that means that they're getting close together at 540 hertz. That means that this frequency is higher than the original frequency. But I don't tell you what it is. It's very mean of me, okay? But that's what it's all about. It's all about challenging yourself, following the steps, see what comes out. Now, when it passes, that means that it's going away. Okay, so there it is. So I've got passing. The frequency changes to now a new listened frequency. The biggest mistake that I saw learners doing on the page was that they were using one of these as FS. I didn't even give you FS. Right, that should be one of your clues. I didn't give you the frequency of the sound or the source. What is the speed of the ambulance? Now I'm asking you for another thing. Now here's your clue. There are 2 unknowns. That is the VS is unknown, Fs is unknown. The only way that you know how to solve two unknowns is using a little bit something inside your grade 10 and 11 algebra, and that is simultaneously. I need to make one equation for the approach. I need to make another equation for the going away, or when they're getting further apart. So let's climb into those. Let's see how we set up those equations, and let's see if there's any time to answer some of your questions there. Okay, but let's get into this. The first thing which I'm going to do is I'm going to set up the equation over here, which actually describes it's one of the two. I want you to try figure out. Some of the questions on the Facebook page were actually asking, how do I know if it's plus or minus without wasting my time, trying it out, figuring out it's wrong? Okay, I want you to see this. When I've got an addition, or I'm making the bottom of my equation bigger, try and think what that does to the fraction. If I make the denominator or the bottom of my fraction bigger, that will make the whole fraction smaller. That means that this guy is going to get smaller. So this whole equation is for when things are moving apart. When the ambulance is driving away, this is the equation to use. So what I'm going to be doing is let's put in our numbers and let's see what comes out. I know that 467 was the listened frequency. When the ambulance was moving away with Vs, remember your 340? That's the velocity of your wave. Now, make sure that you've got your 467 and the plus at the bottom. That's going to set you up correctly. That is equation number 1. The problem is that doing simultaneous on something like this is very, very ugly. Now, I don't particularly like substituting into other equations and doing all this fancy stuff. I want to get one of the variables on its own, and it's usually the variable which I want to get rid of. I was not asked for the frequency source. So what I'm going to do is I'm going to get rid of it by making it the subject of the formula. Now, I can cross multiply and I can move all of this other stuff away very easily if I use some brackets. Now, there's some brackets which are going to help me. Some of them aren't needed, some of them are, but it helps me actually think about how to move around this question. Now, it's going to get really full of maths here, so stay with me, buckle down tight, we're going to go into this now. So, what I'm going to do is I'm going to rearrange my equation. In other words, I'm going to get Fs on its own. So what happened? I needed to move these terms across. This one needed to go down to the bottom. This one needed to go up to the top. And there it is. I've actually moved everything across away from frequency source. I've made frequency source the subject of the formula. Very, very nice and difficult. You guys that are not that great at maths, I want you to write this down. I want you to look at this tonight and make sure that you conquer your fears. We've got frequency source on its own. Now, some of you in maths have actually been taught to make this an equation 1. So what we're going to do is now we're going to set up for equation 2. We have done for the path towards, so that was when they were going away from each other. Now we're going to do the towards. I'm sure that you've guessed it. We're going to work with the negative, we're going to work with the other number. And here it comes. Now we are going to deal with what happens when they're going towards each other, as promised. So frequency listened equals V over V minus. That minus is going to make this whole fraction bigger. That doesn't make any sense the first time you say it. If I'm subtracting, I usually make something smaller. But when we subtract from a denominator, I'm going to make the whole fraction bigger. Why would I want to do that? Well, when things get closer together, that means that the frequency is going to go up. So let's see what happens. It went up to a value of 540 hertz. 340 over the 340 there. I leave my same two variables over here. There's a lot of maths on the board. I'm going to leave it there for a moment, just see what people are doing. I want you to try and do the same thing to this as we did earlier on today. I want you to get frequency source to be the subject of your formula. So I like to use the brackets. You don't have to, but it makes my life a little bit easier because I can think of everything inside a bracket as one thing. And I can move it around by doing the opposite to what it's doing here. If I'm multiplying at the top by 340, I divide it down to the other side. If I'm dividing by 340 minus Vs, I multiply it up. What happens to your fraction when you take it over? It cross multiplies and turns upside down. So I'm pretty sure you've guessed it so far. We've got our second equation here, and there it is. I've moved the 340 minus Vs up to the top. 340 has gone down. Now, I've got my second equation. I've got my second equation, which describes what happens when they go towards. So I'm just going to highlight this, and I'm just going to show you that this is what's happening when they go towards each other. I've got two equations. I've done all the difficult signs. All I've got to do now is get them together, get my velocity source out, and get that fantastic answer that's going to give somebody a calculator. I can see Ty hard at work figuring it out. Millions of you guys have managed to get to this answer, and as soon as you saw this, you were working furiously. Okay, really good. It's great practice. This is such a difficult question, and you managed it. Fantastic. Bright future for you guys. So, I've got my towards, I've got my away. The only thing left to do, and there's a lot of maths here, is to put them together. A whole bunch of maths on the screen. I'm hoping that people at home's brains aren't exploding.
Because mine, I'm just looking at it, I'm just like,
There's just numbers everywhere, but we've got to make sure that we're organized. I hope that people can see this. It looks a little bit smaller. I'm not sure if the producer's got it on the screen. I think he will. Okay, but we've got a whole bunch of numbers over here. I've got equation 1 here on the left, which was equal to Fs. This was also equal to Fs. I've also got 540 and the whole thing over here. So equation 1 on the left, equation 2 on the right. Now we can do something really cool over here. And I saw some people on the Facebook page actually typing out the math here, which was really awesome. Okay, because what that does is it gives everyone at home a study opportunity and helps them out. Okay, so if I've got two things which are equal to each other, this is the part which I make it simultaneous. If I've got the same denominator on both sides, something fantastic happens. We can get rid of it. We can make our life much, much easier. I can get rid of that 340 by multiplying both sides by it. So that's a really cool trick, and I'm hoping you're watching on Mondays to our math show because that's something you should know. Okay, so 340 is out of the picture. Let's deal with the rest of the numbers here. So if I've done that, I've dropped my 340 out of the picture. This is what we're sitting with. You are dealing with a normal linear equation. All we've got to do is go fish out our delicious velocity of our source or velocity of our sound, and here it comes. We're getting there. We're so close. I'm moving quite quickly here because I want to answer a question or two. I'm going to multiply n. I'm going to distribute into each one of those brackets. And there it is. I come out to my final answers. Lots of big numbers here. 158,780, and then 467 Vs, because remember that I had to distribute all the way into both those brackets, and the same with 540. I've done all of that. And what we're going to do is we're going to show you the answer now, and we're going to see how people cope with that. So a whole bunch of maths here, all to arrive at one number. And there it is. It's coming. There's my answer. If I solve everything, divide through by 1007, and I divide both sides by that number, I come out to a grand total here of 24,62. I know that some of you got 24,65. That's fine. That just means a slight rounding difference. Okay. But that gets us to only one of those answers. If I get this total answer, that's going to get me to the total answer of D. So manage to get D. That means that you're doing something right. You know Doppler backwards. That's fantastic. How are we doing on the Facebook page? Some questions? Are people happy about this?
I think everyone was generally just focused on the challenge question because they were saying that this was a whopper. This was a tough one.
Okay, well then what I'm going to do is I'm going to take 3 or 4 minutes. I'm going to run through this answer again. Sadly, this is something which I actually found inside an answer for one of the final papers. Okay, now I don't particularly like this. This was one of the papers which was written in February, March. They're usually a little bit more difficult, but I was surprised to see something like this. Okay, they can put simultaneous questions inside your final papers. One of the things to look out for is if there's 2 things which I don't know and 2 situations. That's a surefire sign that you've got to deal with 2 equations. Okay, so let's take a look at how we managed to pull off this amazing feat, and let's just highlight our answer because most of you at home were working towards that. If you rounded off your answer, there it was, option D. Now remember, we had one situation for the approach, which was 540, and then one when it's going away for 467 hertz. That means that you've got to deal with 2 equations. Set them up, okay? And then I'm asked to tell what is the speed of the ambulance, VS, the velocity of the thing which is making the sound. What is the speed of sound? We need to know. Remember that that is my V, which I need to know before I climb into this question. How did I set it up? The pluses and minuses is something that most people are struggling with. So I'm just going to go through how I chose those again. I chose the plus in this case when the objects were going away from each other. So in the first part, remember that I summarized that this was when they were going away from each other. Remember, when things go away, what is my prediction? That the frequency is going to go down. So when I take this number for the frequency which goes down, let's just get those arrows out of the way. It's cluttering things a little bit. When I've got 467, that is the hertz which is lower than the other one. That means that they're going away from each other. And that's why I've got this plus. That plus is going to make this fraction smaller. This fraction, this entire thing is going to be less than 1 because I'm adding to the bottom. I'm adding to the denominator inside that fraction. So if you can't figure it out, you can actually deal with a normal fraction. So start out with something simple. Start out with 4 over 4. What happens if I start adding to the bottom of that fraction? If I've got 4 over 4 and then I change it to 4 over 5, I've made my fraction smaller by making the bottom bigger. And that's what I've done here. So just check it with actual numbers. If you can't think theoretically and you don't like working without numbers like we've got here, I want you to actually deal with numbers. Much, much easier. So just a quick summary before we go on there. What happens in the case when they're moving towards each other? The minus. I make the bottom smaller. So start out with your simple fraction. 4 over 4. What happens if I take away from that bottom? I get 4 over 3, which is bigger than 1. So it's a very, very easy way to check yourself, to check your thinking. Actually put numbers into your theory. Test it. See what happens. There is my number over there. It's 540. That was an increased frequency. That agrees with the prediction. When objects are heading towards each other, that frequency is going to be higher. And there it is. It's minus. I hope that you can choose that. Remember, you can always fix it later on. Ty, I think that's all the time we've got for questions, eh?
All right. Yeah, it was a tough one. My brain was just like, overload. Okay, I got it, then overload. And I was like, okay, I got it. But guys, if you're at home and you're following and you had fun, it's just as much as me and Phil had fun, guys, keep chatting on the page to each other. That's why the page is there. And guys, again, I'm like, you guys were on fire. So I'm going to have to sit and literally go through the entire page because you guys were just answering this. And I'm so impressed, guys. I must say, congratulations to you guys. You matrix are working hard. Phil's also impressed. So guys, again, I hope you guys had fun. You know, you guys, this platform is for you. So you guys, always, when we're on, chat to us so we can get those questions to you guys. And yes, Phil, we have a special request from Indiana. She didn't actually want me to tell you this.
Oh, yes.
But I was just like, she'll deal with it. I'm going to spill the beans. She said she has a huge crush on you. So. And I'm sure a lot of the other lady matrix out there, you know, Phil, I'm just trying to be a wingman. But anyway, on that note, guys, we'll see you next time. Bye.